Hey guys, welcome back to Genius Learning. So I want to take a look at some derivatives, and in particular I want to look at some implicit differentiation. Okay, so we want to take the derivative of this, right? And implicit differentiation, we need to write dy dx every time we take the derivative of y. So we need first a little bit of understanding. So arctangent, okay, let's say just of x, right? And let's say we take the derivative of that. So we're gonna have the derivative of x, whatever's in here, we're gonna have the derivative of that over 1 plus x squared, whatever's in here squared. So this is the derivative of arctangent. Okay, so that's the first thing we need to know. And then product rule in here, right? So we're gonna have f times g. So f is gonna be the x squared, g is gonna be the y to the third, and we're gonna do fg prime plus fg prime. So f prime g plus fg prime. So we're gonna have that, okay? So now we can get started. All right, so we wanna do the derivative of arctan first, right? And every time that we take the derivative of y, we're gonna write dy dx next to it. Okay, so I'll show that now. So the derivative of arctangent is the derivative of the inside. So the derivative of this is already gonna be a product rule on top. Okay, so just for notation, I'm gonna write this. I'm gonna write x squared y to the third, and just show that we need to take the derivative of that. Okay, over 1 plus x, which is inside here, which is all of this. So we got x squared y to the third squared. Okay, and then all that is going to equal this side. So let's take the derivative of this side here. So we bring down the 4, right? We keep everything inside, and we lower this by 1. So that'll be 3 times, right? Chain rule, the derivative of this entire thing in here, right? Which is just gonna be 2x. Okay, so for this side here, we're done. Let's take the derivative of this up here. Okay, so product rule, we're gonna do 2x, so the derivative of the first term, right? This term comes along. And we didn't take the derivative of y, so we just took the derivative of x, right? And then g just comes along. So it's only when we take the derivative of y that we write dy dx. So then we do plus f, or plus x squared. And now we do the derivative of the second term, which is y. And so we're gonna get 3y, and we take away 1 from the top. Okay, and because we took the derivative of y, we're gonna write dy dx right next to it. Okay, and that's it for the top part. So now, okay, we're gonna rewrite everything. Here we can combine these two terms, right? So that's gonna be 8x, and then we're gonna have x squared plus 1 to the third. All right, and our goal is to isolate dy dx. Okay, so I'm gonna take this entire bottom part and move it to the other side. Okay, so I'm gonna write this again here. We got 3 x squared y squared, right? We got dy dx. Okay, and I'm gonna write this with this term multiplied over here. So I got 1 plus x squared y to the third squared. All right, and then once I move that over, now I want to take this term and subtract it to that side. So then I'm going to have minus 2x y to the third. Okay, so now all that's left to do is divide by this term to isolate the dy dx. So dy dx, and then finally we have 8x x squared plus 1 to the third. We still have everything here in the parentheses. So we have 1 plus, and you can distribute this exponent. I'm just going to leave it like that. All right, we still have this minus 2xy to the third term. And now what's new is that we divided this to the other side, so then we get 3x squared y squared. Okay, so then we have solved for dy dx, which is always the goal when we're doing implicit differentiation. Okay, so just a quick example on some derivatives you might see along the way in some calculus. All right.